Hi, I'm Benny D, and in this video we're going to have a look at types of functions and implied domain. So a function is said to be a one-to-one function if each x value maps onto a unique y value. Okay, so for example, all linear functions are one-to-one, whilst quadratics are not. Okay, so to test if a function is one-to-one, we do a horizontal line test. This is exactly the same as the vertical line test, just horizontal. Okay, so if we have a look at these ones, okay, we've got an example here. Are these functions one-to-one? Okay, well, we need to be thinking about tracking across like a vertical line test. It's just now we're doing a horizontal line test. Okay, it only crosses this function in one spot. Okay, and anywhere I draw a horizontal line, it's going to only cross this function in one spot. So that would be a one-to-one. So 1, 2, 1. If we have a look at this one though, okay, we can see I can draw a horizontal line here. I can draw a horizontal line there. But there's a region in the middle here that when I draw my horizontal line, it touches in multiple places. Okay, so that means it's not a one-to-one function. Okay, it doesn't pass the horizontal line test. Now, if I look at this last one here, I can see, hey, I'm going through everywhere. Hey, no dramas, passes a horizontal line test. But this is not a one-to-one function because we haven't actually passed a vertical line test. So don't forget that. Don't jump straight into, hey, is this a one-to-one function? Because this one actually doesn't pass the vertical line test because we cross it in two places there. Okay. Now, what actually happens if we don't have a one-to-one function? Hey, then what we have is a many-to-one function. Many-to-one function. Okay, and that's what happens here. Okay, we've got many x values. In this case, with that horizontal line, we have 3 x values giving the same y value. So that's why we have many x values giving the one y value. Okay, this one here, okay, that wasn't a function. This is a one-to-many relation. Okay, it's not a function, but it's a one-to-many because the one x value gives many y values. Okay, and we can actually have many-to-many. Okay, and the idea with that is a circle is a good example. Okay, because my one and my x value here will give multiple y values there, and the same here. This x value is going to give this same y value that I had over here, and so we actually have a many-to-many in that case. Right, so that's our idea of functions, whether they're one-to-one or not. Then we can have a look at our next little section in this video, which is about implied domain. Okay, so when we're dealing with functions, whether they're one-to-one or many-to-one, often the domains aren't actually specified. Okay, in these cases, the domain is the largest set of R, so all real numbers, for which the rule is defined. Okay, this is called the implied or maximal domain. Okay, so if we have a look at this one, okay, find the maximal domain of f of x equals the square root of x. Okay, no domain's been given, but our square root function, we know we can't have negative values. Okay, can't take the square root of a negative. Okay, so it looks something like this. Okay, so our maximal domain for that would be from 0, using a square bracket, because we are allowed to use 0, to infinity. Okay, so you can see here, no domain was given, but our maximal or implied domain would be 0 to infinity. Okay. We can also talk about odd and even functions. Okay, so we see some patterns emerging when we look at functions. Okay, and there's a group of functions that we call odd functions that have the property that f of negative x equals negative f of x. And what that really means is it's got rotational symmetry. So if we rotate the function 180 degrees, we get the same function again. Okay, and all odd degree polynomials are odd functions. Okay, so anything if we've got y equals x to the power n, that n value is going to be odd, then we've got an odd function. And so a function is in the form f of x equals x to the power 1 on a, where a is an odd number. So if I've got, for example, x to the power of 1 on 3, that's actually going to be an odd function as well. Okay, even functions, have a different property, and that's that f of negative x equals f of x. What this means is they're actually symmetric about the y-axis. Okay, and all even degree polynomials are even functions. So of course our quadratic is a good example of this. Coming down and back up. Okay, if we put a negative x value in, so say negative 2 there, okay, it's going to give us the same y value as if we had positive 2. Okay, so that's what we mean there about being symmetric about the y-axis. Okay, and we have some other functions in the form of f of x equals 1 on x to the power n, where n is even. They're also going to be even functions. So an example would be 1 on x squared. So that function just looks like this. Okay, so in this video we've had a look at our types of functions and looked at what it means to have a one-to-one function. We've also had a look at the horizontal line test to see if the function's one-to-one, and then looked at our implied domain and odd and even functions. So hopefully that helps you out with getting through some of your work.